Section 6.2 Interactive Assignment Objective 2. This question, according to an airline, flights on a certain route are on time 75% of the time. Now suppose 20 flights are randomly selected and the number of on-time flights is recorded. For part A, we want to explain why this is a binomial experiment. Okay, now an experiment is said to be a binomial experiment if each of the following statements are true. Number one, the experiment is performed a fixed number of times. Each repetition of the experiment is called a trial. Number two, the trials are independent. This means that the outcome of one trial will not affect the outcome of the other trials. Number three, for each trial, there are two mutually exclusive disjoint outcomes, success or failure. And number four, the probability of success is the same for each trial of the experiment. So we're going to determine whether the experiment satisfies the given criteria. This experiment is performed a fixed number of times since there are 20 trials, the 20 randomly selected flights. The trials of this experiment are independent because each flight was randomly selected and no flight's arrival depends on another flight. There are only two mutually exclusive outcomes. Either the flight is on time or not. And the probability of success on-time flight is the same for each trial because flights on this route are on time 75% of the time. Therefore, since the four requirements are satisfied, the probability experiment represents a binomial experiment. So let's just go ahead and verify that here. We know that we have the following, so C and D and E and H are all results or successful results. Okay, now the next question says, determine the values of N and P. So recall that in a binomial experiment, N is the number of trials and P is the probability of success. So we know that N is going to equal 20 and P, which is equal to 75%, which is the probability of success, meaning that it's going to be on time, is a decimal of 0.75. So therefore, answering this question, we would then say that N is equal to 20 and P is equal to 0.75. Okay, now the next question says, find and interpret the probability that exactly 13 flights are on time. Now the key word is exactly. So, in order to do that, we're going to have to use our probability formula. So when x is equal to 13, we know what our values of n is because we know that n is equal to 20. So we know n is equal to 20, so we know each value of n is going to be 20. Okay, and we also know that the probability is 0.75, so p is 0.75. And we also know that the value is exactly 13 flights. So that means x is equal to 13, which means x is 13 here. Okay, so now if we go ahead and then put this into our function here, we want to find 20 combination 13. Let's just go ahead and do that on our calculator. So if we want to do 20 and then go to math and then go to probability and then select number 3 and then put in the value of 13, and we get 77,520. And we know that we have 0.75 to the 13th power, and 1 minus 0.75 is 0.25, and 20 minus 13 is to the 7th power. So if we wanted to go ahead and evaluate this expression here, we would take 77520 and then multiply that by 0.75 raised to the power of 13, and then times 0.25 when raising that to the power of 7. And so therefore, we're going to get the following, 0.1124. Okay, now again, this is exactly. Now, if I wanted to do this on StatCrunch, then I'm going to go this particular way. I'm going to go first to Stat, and I'm going to go to Calculators, and I'm going to select Binomial. Okay, now in my binomial, down here, we want to make sure in gray that it says standard. And we know the value of n in our problem is 20. And we know that the probability is 0.75. And now down here, we have the probability of x. It says exactly 13, so we need to change this to make sure it says equals. And then we're going to put the value of 13 and then compute. And you can see that we get the same number. We get 0.1124. Okay? Next. Now we can go back and take a look at how we answer this question. So you can see here that the probability of exactly 13 flights are on time is 0.1124. And then they want us to interpret this probability. Now remember, in order to interpret this probability, okay, what we're going to do is we're going to take this value that we got for our decimal, okay, and then round that to 2 decimal places, which is 0.11. Okay, if we want to write this as a fraction, this is 11 over 100. And so therefore, we would interpret this probability to say, okay, that in 100 trials of this experiment, it is expected that about 11 will result in exactly 13 flights being on time. And so therefore, there is our answer. Okay, now the next question is asking us to then find and interpret the probability that fewer than 13 flights are on time. Okay, so what does that mean? Well, that means that we want to find the probability of x being less than 13. Fewer than. It doesn't say at least. It says fewer than, so we cannot include the 13. Well, technically, the definition means that the probability of 0 or the probability of 1 all the way to or 12, which means we have to find the probability of 0 plus the probability of 1 all the way to the probability of 12, which means then we'd have to find the formula for each individual one. Now, unfortunately, this is going to take quite a bit of time, so we can actually use either the calculator or we can use StatCrunch or we can use a table. So since we've been using StatCrunch here, I'm going to go ahead and show you how to use StatCrunch. So I'm going to go back over here, okay? And so now we already have the fact that n is equal to 20. We already know that the probability of 0.75, and now we just need to change our inequality symbol here. And we know it has to be less than. Okay, so remember that fewer than represents less than. So we're going to come over here and we're going to select less than, and then we're going to select compute, and you're going to see here that we get 0.1018. And so therefore, it's going to give us the probability of 0.018. Now, if we wanted to then write this as a fraction, round it to 2 decimal places, this is 0.10, which is the same thing as 10 over 100. So how would we interpret this? We would say the following. We would say that in 100 trials of this experiment, it is expected that about 10 will result in fewer than 13 flights being on time. So if we take a look at our answer, we got 0.1018, and interpretation is in 100 trials of this experiment, it is expected that about 10 will result in fewer than 13 flights being on time. Now in part E, it says find and interpret the probability that at least 13 flights are on time. Okay, now remember the key word is at least. Now when we talk about at least, we always deal with the complement. So that means that the probability of x being greater than or equal to 13, which is at least 13, is equal to 1 minus the probability of x being less than 13. Well, we found that in our previous example in part D, we found that the probability of x being less than 13 was 0.1018. And so therefore, we would get 0.8982. Now, if we wanted to use StatCrunch, we could, okay, because we can now write this as the following. We can say that we can change this inequality symbol to be greater than or equal to 13. And if you notice, when we compute this and round this to 4 decimal places, we would get 0.8982. Okay, now if we wanted to round this to 2 decimal places, we would get 0.90, which is equal to 90 over 100 as a fraction. And so therefore, in order to interpret this, we would say that in 100 trials of this experiment, it is expected that about 90 will result in at least 13 flights being on time. So let's verify our solution here. We can see that the probability that we get is 0.8982. And interpreting this probability, we would say that in 100 trials of this experiment, it is expected that about 90 will result in at least 13 flights being on time. Now the last question says, find and interpret the probability that between 11 and 13 flights inclusive are on time. Inclusive meaning that you have to include both 11 and 13. So let's take a look at how we would write this out. So we would find out that the probability of x being in between 11 and 13 inclusive, which means we want to find the probability of 11 or 12 or 13, which is the same thing as the probability of 11 plus the probability of 12 plus the probability of 13, which means that we would plug into the formula. We know that n is 20, and for each value of x, this means that we're finding exactly 11 plus exactly 12 plus exactly 13. So you can see that we would find this formula and we would get the following, 0.2004. Now, if we wanted to use StatCrunch, now again, you want to make sure you know how to write this out so you know what the definition means. And so now we're going to come in here and then take a look at StatCrunch. Now, in this case, it's asking us for it to be between 11 and 13. So we're going to select between, make sure that's grayed out. We know that n is equal to 20. We know the probability is 0.75. So we know that the first number is going to be 11 and the last number is going to be 13. And then we're going to select compute. And you can see here that if we round this to 4 decimal places, we would get 0.2004. And so therefore, that would be the probability. Now, if we wanted to round this to 2 decimal places, we would get 0.20. Writing this as a fraction would be 20 over 100. So in order to interpret this probability, we'd say in 100 trials of this experiment, it is expected that about 20 will result in between 11 and 12 flights, inclusive, being on time. And therefore, in our solution, we can see that we get the probability of 0.2004. And then interpreting this probability would say that in 100 trials of this experiment, it is expected that about 20 will result in between 11 and 13 flights, inclusive, being on time.